Hello, chemistry people. Welcome back to 2021. I am still Amy, but I am now back in my office at school, which is quite nice for a change. I am just making a quick video here for the IB Topic 1, stoichiometry, trying to calculate some empirical formulae. So this is just on empirical formulae. Hopefully it'll be a quick one. So for me, the best way to teach empirical formulae is actually just to jump into them and start working through. So while I switch over to my OneNote, I'm just going to pause for a tick. So the word empirical is really important, and I say this as somebody who is both a chemistry and a TOK teacher. The word empirical comes from a particular philosophy which says that the truth can only ever be found by experiment. Now, as a chemistry nerd, that sits really well with me, that we can only know what's going on by actually doing the work and getting experimental results. So, in class, I will talk through how we actually do these experiments, and we are going to be doing one of our own. But for now, let's actually look at the steps of calculation. So an oxide of chromium, so it only has those two elements in it, is found to have a percentage composition that is, sorry, I'm just double checking that my microphone is still working. Hopefully that is still working, yes. So the percentage composition that is 68.4% chromium and 31.6% oxygen. Please note those are by mass. So hopefully, if your brain is in the game, you should be thinking that, okay, so those are masses. At some point, I'm going to need to convert to moles. So I don't know if you can hear me crinkling about in the background, but I am just getting to a periodic table. So when you're doing an empirical formula question, the first thing I will always do is draw up a table that looks like this. So I have chromium and oxygen by mass. I have 68.4% chromium and 31.6% oxygen. What I then need to do is the step of calculation that will convert those into moles for me. So let's divide those by their molar masses. So chromium is 68.4 divided by 52.00. Now, excuse me a second while I get to my calculator. 68.4 div 52 enter gives me, sorry, my pen is plugged in, so I'm a bit tangled, 1.32 moles. For oxygen, it's 31.6 divided by 16.00. So 31.6 div 16 gives us 1.975. Now, it does not make sense to have 0.3 of an atom. So what we need to do, we need to convert these to ratios. Sorry, I didn't realize I had my stroke eraser on, not my line eraser. There we go. So what I'm going to do now is I am going to divide both by the smaller number. So that is obviously going to be my chromium number. So 1.32 divided by 1.32 gives me 1. And then my 1.975 divided by 1.32 gives me 1.50. Now again, having half of an atom does not make sense. So what I do here is I go, okay, logically that means I should just multiply everything by 2 to say that I have 2 chromiums for every 3 oxygens. So I have just calculated the ratio of atoms of chromium to atoms of oxygen in this compound, which means that it has an empirical formula of Cr2O3. Let's do the next one, because hopefully you can see that my pattern is exactly the same. So I have silver, nitrogen, and oxygen. So my table is a bit bigger this time. So silver, nitrogen, and oxygen. I start with my mass. So it is 63.5% silver, 8.2% nitrogen, and 28.3% oxygen. My next step is to divide by my molar masses. So silver is, oh, that was about to write down gold, 63.5 divided by 107.87. Nitrogen is 8.2 divided by 14.01. And oxygen is 28.3 divided by 16.00. And then I've got moles. So let me just pop those into my calculator. So 63.5 divided by 107.87 gives us 0.589. Nitrogen, 8.2 divided by 14.01 gives us 0.585. 28.3 divided by 16 gives me 1.77. So my next step is to divide by my smallest. Which is my nitrogen. Okay, so 0.589 divided by 0.585 gives me 1.01, and then 1.77 divided by 0.585 gives me 3.03. So I am going to say that that is approximately equal to, oh, sorry, I should probably use the actual maths version of that. So approximately 1 to 1 to 3. So I am saying that my EF is AgNO3. Whenever you are calculating these empirical formulae, you are just replicating this table over and over again. So, thank you for watching this video. Excuse me a tick while I pause and move back around. Thanks for your attention here today. If you are in my class, please feel free to email me if you've got any questions. We will be practicing these some more in class next week, but I did just want to introduce them so you could have a go at some of these questions before we get into our experiment that we're doing next week. Thank you so much. Have a fantastic rest of your day, and here's hoping that 2021 is better than 2020. Thank you. See ya. Bye.